Hello students, and welcome to your chemistry lesson. Under today's lesson, our main focus is ionic bonding. What is a chemical bond? Well, a chemical bond is simply joining of two or more particles by chemical means. These particles can be atoms or molecules. They can even be elements. Chemical bonding is very important. This is as to make elements stable. If you can remember, elements in their elemental state, which is just in an element form, are not stable except the group 8 elements. Group 8 elements are the only stable elements on the periodic table, meaning group 1, group 2, 3, 4, 5, 6, 7 are all unstable. So bonding occurs for these elements to become stable. Now, what are the types of chemical bonding that occur in chemistry? Well, there are mainly three, and two will be done in detail. The first one is ionic bonding. This is a type of bonding where two or more ions come together, then they exchange electrons. Then because of that exchange, they become bonded to each other. And we said this is the type of bonding that we'll be doing in this lesson. Another type of chemical bonding is covalent bonding. Covalent bonding is the sharing of the valence electrons. So two elements again will come together, then they'll share or both will donate electrons, making these two ions stable. Covalent bonding is usually common under nonmetals. When we look at it in our following chemistry lesson, you get to know it. You can see there's the word co and valent, and you can remember we talked about something relating to valence here. So it's the valency electrons being shared. Then the last but not least is the metallic bonding. Metallic bonding is the type of bonding that occurs among metals. We won't go so much in detail of metallic bonding, but for ionic and covalent, it's a must. You need to know them and be able to represent these types of bonds. With that said and done, I'm sure now we can start looking at ionic bonding. We already know what ionic bonding is, right? It's the type of bonding where two or more ions are joined together by the exchange of electrons. Now, we know that already. We can define it very well. Apart from the definition, I want you to always remember that ionic bonding will involve mainly two ions, okay? I don't mean the number, but the types of ions. Two types of ions. As you can see on screen, to involve the metal ion and the non-metal ion. In one of the lessons, we said elements in the periodic table will react to complement each other. So a group 1 metal can react very well and simply with a group 7. Why? Because we know that metals give electrons while non-metals receive. It's very important to know that metals give electrons while non-metals receive. So a metal will give one electron, then a group 7 will receive that electron, then they'll become stable. If you can remember, for us to know that an element is stable, octet rule and duplet rules should be satisfied, okay? So when a metal loses its valence electrons, it becomes stable by satisfying the octet rule. Let's imagine this so that it's very clear. Let's say we had the ionic compound sodium chloride, which is table salt, the salt that we have in homes. So we started this example so that there's a good understanding. Sodium chloride is an ionic compound. There's the metal ion of sodium and the non-metal ion chloride, or simply the chlorine ion. You agree with me that this is the sodium in its elemental structure. This is the electronic configuration of sodium, and while this is the electronic configuration of chlorine. You can see they are like opposites of each other when we look at the valence shell, okay, the outermost shell. You can see sodium has 1, then chlorine has got 7. So what happens when ionic bonding will take place is simply the exchange of what? Ions. And we said metals give while non-metals receive. So that one electron will move from sodium here, then be transferred and given to chlorine. After that, you agree with me that when this one electron moves away from sodium, there'll be 8, and sodium will be stable. This also happens to chlorine. When it receives 1 from sodium, it will have 8 in the outermost shell, and therefore the octet rule will be satisfied. Now, is this all? No. To represent the bond, we need to do some other drawings that are very important. If you end your answer here, you'll be totally marked wrong in an exam. Now, what do we do to finish up everything? We draw the sodium ion like this, put some braces that are square, then we also include the chlorine ion. Now, before we do anything, I want you to notice that for chlorine, after it gets the electron from sodium, that electron is drawn as a cross and not a dot. In every question you do, be sure to differentiate between the types of elements that have been used. One would be a cross and dot. So this is the dot and cross representation of ionic bonding. You see, one element has got dots while the other has got crosses. It's very important to show this difference here, where you can see that there's a cross there while the others are dots. It just shows that this electron comes from sodium. And you agree with me, if you can pause the video, check if both the duplet rule and octet rule are satisfied, you find that that's so. I'm sure you pause the video now, you have proved. To finish up this question or this example, we need to add a part of charges. What's the charge of sodium and what's the charge of the chlorine ion? Well, for sodium, it's 1, so we just put a single plus. Then for chlorine, it's -1, so we just put a single minus. When we do this, we have completely shown the ionic bond of sodium chloride. And if you're asked to do so, this is how you're supposed to do it. We just look at sodium chloride. Sodium chloride is a very simple ionic compound. What if we looked at another one which might be a bit confusing for some people? Let's look at magnesium chloride, which is another ionic compound. Magnesium is in group 2, while chlorine is in group 7. So these do not just simply complement each other like I said in the lesson. There are some questions or ionic compounds that will be very easy to complement each other. For example, a group 1 and group 7 will easily complement a group 2 and 6, a group 3 and group 5, a group 4 and a group 4. So those will easily be bonded to each other, as there won't be some tricky questions you start asking yourself. So to prevent that, after you watch this lesson, I said, well, let's look at another ionic bond. And I chose the compound magnesium chloride, okay? We know magnesium is drawn like this. Don't forget, it's got 2 electrons in the outer shell. Yes, there are 2 electrons in the outermost shell. Then we've got chlorine that we just used. Now, it's very important for you to understand why there are 2 atoms or chlorine elements. You see? Now, let me explain why. Magnesium has got 2 electrons in the outermost shell. You agree with me? Yes. Now, magnesium is bonded ionically to chlorine. Now, think about it. Chlorine only needs 1 electron for it to be stable, right? While magnesium has got 2 electrons in the outermost shell, meaning it needs to give away all these 2 electrons in the outermost shell for it to become stable. But when only 1 chlorine is involved, only 1 electron in the outermost shell of magnesium will be given away. and it will be still left with one. So what happens? Since the bond is between magnesium and chlorine, when magnesium is not stable after giving away one electron, but one chlorine is stable, what happens is that another chlorine atom will come and also receive the other electron that has been left. One goes to the first one and another to the second one. It's very important to remember this fact. When one fails to satisfy the other, right? Yes, there will be need for holding more of that element, okay? As in chemistry, we will have many compounds that might even involve 3 elements bonded to one, 4 elements bonded to one. Yeah. Sometimes it might be non-metals in this case where we need more chlorine. Sometimes it might be more magnesium. Let's say we are bonding sodium and oxygen, okay? So oxygen needs 2 electrons, while sodium can only give 1 electron, meaning we'll need 2 sodium elements to give 1 electron each, then satisfy the 1 atom of oxygen. You see? So in that case, there are 2 metal ions involved and 1 non-metal ion. But in this case, we're looking at 1 metal ion and 2 non-metal ions. So since we know this is what is happening, I'm sure it's simple. We'll just do the same as we did for sodium chloride. We get our magnesium and draw it in these square braces. Then now we come to the tricky part that confuses some people. Well, what we do is in this lesson we arrange them like this, which is the easiest to remember. As you can see, I try to be consistent in the arrangement. You can write the magnesium here, then the other 2 atoms of chlorine by the side like this. Then we should never forget that they are charges, okay? So for magnesium, it had 2 valence electrons, and when it gave them away, it became positively charged as there were more protons than electrons, you see? So its charge is 2 plus. For chlorine, we already know it's negative and negative. This is how we can represent the chemical compound magnesium chloride. Now, there's another thing that's very important under ionic bonding, which is the properties of these ionic compounds. Each of those types of chemical bonds we said earlier, which are ionic bonds, covalent bonds, and metallic bonds, each of the compounds produced by those bonds has got properties. In today's lesson, we're looking at ionic bonding. So we'll be looking at the properties of the compounds that are ionic. The first property is crystalline. What does this word crystalline mean? For some, it's the first time they're hearing it. For some, they already know it. Crystalline is just simply the name given to a compound or a substance when it's in a crystal form. The best example I can give for you to understand this property is the table salt we looked at earlier. Table salt is crystalline. It's in form of crystals. So all compounds that are a product of ionic bonding are crystal in form. This is because of the regular pattern in which they bond together. The patterns are standard, you see. When we talk about these ionic compounds, the ratios are the same always, they never change. So sodium chloride always have 1 sodium ion and 1 chlorine ion. That never changes. The other property is their boiling point. They've got a high boiling point. I'm sure if you can guess, this is because of the energy that is required for 2 ions to bond. In chemistry, when we look at other topics, we'll come to know that when breaking a bond, we need the same energy as we used to make that bond. So For ionic compounds, for them to boil, they need a lot of energy to start separating that sodium and that chlorine, because a lot of energy is used when bonding these two ions. So with that said and done, let's look at the third one. The third one is that these ionic compounds have got a property to be soluble in water. Or simply we say ionic compounds are soluble in water. When you get an ionic compound and put it in water, it will dissolve, okay? Perfect example is salt again, the table salt we have, okay? Let's think of ORS, the oil rehydration solution, okay? When we get some salt and sugar, both are crystals, so they can be ionic compounds. Put into water, we stir, we get a salt and sugar solution, okay? We drink that, it can rehydrate the lost fluids in a dehydrated person. So that's one of the properties of ionic compounds. They are soluble in water. The last but not least is that they do not conduct electricity as solids. For ionic compounds to conduct electricity, they need to be in the state which is a bit liquid-like. They shouldn't be solids, but they should be liquid-like. They conduct electricity in their molten states, in states which are a bit like a liquid, okay? When we say molten, it's a term used to mean a substance made liquid because of heating. So that's all for today's lesson.